Graphs of exponential functions. Usually when we want to graph an exponential function, what we'll do is we'll just use technology. So in this section, all we're going to do is just highlight some of the features of the graphs of an exponential function. So shown here is a graph of the function 2 to the x. And so let's just take a look at some of the function values. So we'll take a look at some of the negative values. We'll take a look at 0. We'll take a look at some positive values. So 2 to the negative 2 is 1 over 2 squared, or in other words, 1/4. 2 to the negative 1 is 1/2. 2 to the 0 power, anything to the 0 power is 1. 2 to the first is 2. 2 squared is 4. 2 cubed is 8. So when we look at the graph of this, we can see that in the negative direction, as x goes to negative infinity, the values are going to be getting smaller and smaller and smaller. And as x goes to positive infinity in this direction, the values of the function are getting larger and larger and larger. And notice that the graph is going to go through the point 0, 1, so that'll be the y-intercept of the graph. Notice that it doesn't matter what the base is, anything to the 0 power is always going to be equal to 1, so all exponential functions are going to pass through this point 0, 1. Let's take a look at this function. Now this is the function f of x is equal to 1/2 to the x power. And so again, let's take a look at some of the values of the function so we can understand what it is we're looking at. We'll take a look at some negative values. We'll take a look at 0 and also some positive values. Okay, so 1/2 to the negative 2 power would be the same as the reciprocal of this. So that would give us a value of 4. 1/2 to the negative 1 power is the reciprocal again, which would give us 2 to the first power. Here we'd have anything to the 0 power being 1. 1/2 to the first power is 1/2. Squared is 1/4. Cubed is 1/8. So you can see that as x approaches negative infinity, the values of this function are getting greater and greater and greater. As x approaches positive infinity, the values for the function are getting smaller and smaller and smaller. And again, the function is going to pass through the point 0, 1. So the first function we looked at, for example, f of x is equal to 2 to the x, is an example of exponential growth. So when b is greater than 1, when your base is greater than 1, you're looking at exponential growth. Your domain is all real numbers. So there's no number that you can't use as the exponent of a function. For the range, notice that the range, when we look at our y values, the range is going to be all positive real numbers. And an asymptote is the x-axis, because as x approaches negative infinity, f of x approaches the x-axis. In other words, f of x approaches 0. And remember, horizontal asymptotes define long-term behavior. In the second example, what we were looking at of 1/2 to the x, that's an example of exponential decay. So when your base is between 0 and 1, you're looking at exponential decay. Again, when you look along the x-axis, the domain is all real numbers because there's no number that you cannot use as the exponent of an expression. The range, again, if you look at the y-axis, you can see that the range is the same as for exponential growth. The range is all positive real numbers. And similarly, our asymptote is the x-axis, because as x approaches positive infinity, the function values will approach 0, or in other words, the x-axis. So those are just some of the features of exponential growth and decay functions. If you ever wanted to graph one, you would just take out your technology and make a graph of one.